say hi to Ryan. Okay, so now which way should I? You know what? I'll go through them and then you tell me which technique. All right. So the first one, the integral of 4x squared e to the x parts tabular turbo parts. All right. I'm gonna be color coded. All right. The second integral, you want to do that? Yeah, you'd have to divide each term separately first, right? Yeah, I'm gonna run out of colors and I'm gonna stop. Oh yeah, that's too much. Okay. Oh, I wonder if anyone's gonna get this one. Nice. Does anyone know what tan squared equals? Get out of town. Secant squared x minus 1. Well, you have to know sine squared plus cosine squared x equals 1. And if you know that, you divide through by sine squared or cosine squared if you need it. Sorry, we already covered that. Okay. Now, the next one. Yes, Kevin. U-Substitution. Let's cook. This is kind of pretty the way it's working out. That's it. Oh, wow, that is nice. Yeah. I'm gonna... All right, so at least, hopefully that means you have a clue what you have to do. Now I want you to look through that and ask questions on any of these, or if you have other questions, it's all up to you now. Okay. Yeah. Can I come there? I don't know. Can you meet me halfway? Huh? You're looking at 14. Oh, okay. 2x. Yes. Wait, Jared wrote I hate calc on his notes. So we have to stop the recording. Alright. We're looking at number 12, you said, right, guys? Okay. So it was x squared e to the 2x? Nope. Oh, 14. Sorry. Can I do 14 then first? Because that's what you wanted, right? Okay. Sorry, 14. Oh. Yeah. I know what you're saying. Okay, so we can do the tabular method here because x squared differentiates down to 0, and e to the 2x, e to the u, we can keep integrating that. And so when we do that, I know you got the x squared 2x to 0, but on the other side, the e to the 2x, you have to take the antiderivative. And if you want to take the integral of e to the u, you need du. So if you wanted to on the side, if you want to integrate e to the 2x, what would you need? You would need a 2, because your u is 2x. So you would need a 2, so you have a half. See, now you have 1 half integral of e to the u du. So you have 1 half e to the u. So it's 1 half e to the 2x. Now every time you integrate e to the 2x, you need a 2, so you have another half out front. And it's going to keep, yeah, so then the next time it would be 1/4. And then the rest you're okay with? The alternate sign. Yeah. Okay, now I'll do 12. 12. So this one, you write the gradient inverse line of x. This is one of the great uses of integration by parts. It allows us to integrate inverse trig functions and log functions. Like we know how to find how to differentiate them. But the antiderivative, you need the parts. So it's going to just be regular integration by parts. And other words, the integral of u dv, help me out, equals, so you have to choose your u, and we use light bit to choose the u, and you get down the whole, well, inverse sine, so that's the I line, but there's no log, so the inverse sine of x, that's your u. Question. Yeah. So dv is just dx. So v is just that. And then you have to remember the derivative of inverse sine of x. Here. Now when we put it together, alright, we get uv. I'm going to do vu. It'll look better. Alright, x inverse sine of x minus the integral of v du. So we're going to wind up with an x over, right, square root of 1 minus x squared. And now that's a like that. So to integrate that, now do you want me to write out what u equals, du and all that? Yeah, okay. Some people are saying yes. So for that over there, what are you going to make u? And minus x squared. So du negative 2x dx. Okay, so before I can rewrite that in terms of u and du, I got to make sure I've got the factors of du over there. Half on the outside, a negative half on the outside, and so it will be a half. Right. So we have to put it on sum. So we need a negative 2 here, so we need a negative 1/2 up there. Yeah. So now what we have is x times the inverse sine of x plus 1/2. Now, we're not talking about the old u's and dv. This is the new u, for the u sub over here. This is just du over. I'm rewriting it now. You're good at doing it without rewriting it first. It's fine. How do you... Yeah, you have to rewrite it as u to the negative 1/2. Then we can use the power. Yes. But this is u to the negative 1/2 u. You get from the antiderivative 2u to the positive 1/2. Now we just got to put the u back in. Half the cancel. So we have x inverse sine of x plus, that's just u to the 1/2, so it's just minus x. That's fun. U sub inside of parts. Question? Yes. 10? Alright, what did your 10 first? Can you read me 10? No. Yeah. People usually remember it's something with secant tan, but they don't remember the operation, but you did. Yeah, you have to multiply this by 1. That's the only thing you're allowed to do in this life. Multiply by 1 or add 0. And so 1 is anything over itself. So what is it again? Oh, you're doing it in that order? Okay, look at that. Tan x plus secant x. Changing it up a little. Alright, no. Up. Change things. I know. But then you said you already wrote it. Oh, all right. Well, we're gonna distribute. No, it's the same thing, right? Because when we distribute, we have secant x tan x plus secant squared x. Now it's a du over u. You see that? That's why we do. Because now if you make the whole denominator u, the numerator is just du. Sure, the order. See it? So then, since this is just a, I'm not writing out what u and du is, so since you have du over u, you just get the natural log of the absolute value of u, which is tan x plus secant x, or vice versa, whatever you like. So yeah, you got to remember what to do for the secant. Just like with tan or cotan, you have to. What do you have to do for tan or cotan? Rewrite it. 18. 12 was what? The inverse sign you want to do by parts. Oh, good question. Okay. Okay, he just asked a really good question. Guys, we're not very consistent in our notation. This is not this. Inverse sign is, and it's so confusing because we use the -1 to mean multiplicative inverse, then we also use -1 to mean the inverse of a function. And they're two different things. So yeah. You said 18 next? Okay, what was that one? Yep, the whole question is, what's your u? Okay. I didn't really need this. Really, I should have one. Okay. So, u is equal to 1 plus 1 over x. Okay, so do we need anything? Let's rewrite it. In terms of u and du. So we have minus the antiderivative of u cubed du. You want to take that step, unless you're really good at it, because this is where kids make mistakes. I'm going to write u to the fourth plus c, and now we'll just put u back in. Negative 1 plus 1. So u sub, making a hard sign, and 3. Nice. Sorry. Do you want me to do the 22 also? No. Alright, Isabel, because last time I didn't listen to you, so this time I'll listen. 22, so it's tan squared x. Anything else? Mine, yeah, the do now. Yeah, it's 22, we switched it. Remember sine squared x plus cos squared x equals 1. If I want to get tan squared, what would I divide through by? Sine squared, cos squared. So if you divide every term by cosine squared, you'll have tan squared plus 1 equals. So we can see that we divided every term of the original Pythagorean trig identity by cosine squared, and we got this one. That's the only one you have to know. You divide it through either cosine squared x or sine squared x to get the other two. So So what are we going to replace tan squared x with? See, tan squared x minus 1. Well, now, you just integrate them separately because it's subtraction. So, yeah, it's just tan x minus. Now we'll do 23. Yeah? I want to see what this one is. Thank you. Wait, I'm sorry, which? Oh! So down here it's a 1? Oh, it definitely is wrong. ln rad x. Nice. How great is that? She split them up. That's one of those sneaky U's. The rad x, the 1 over x. Those are the sneaky U's. You gotta kind of take them out of the shadows. So we'll rewrite that as the ln of rad x times 1 over rad x. Make sure you see if I write it as multiplication. Alright, so what are we going to make the u? Okay, so u equals the ln of rad x. What'd I do? Oh yeah, that is what I wanted to be. Wait a minute. We have 2 ways we could do this? That's right, that's why I like math. It's just one way. Yep. Alright, let's try it this way. What happened? Then we'll go back. Let's see if one of these ways works and the other doesn't. Where to go? Slow. Okay. Alright. Yeah, you know what? I don't know if this is the best idea. So did this. Wait, no, I think this is good. No, it's not. Maybe it is. I gotta see it. This is exciting. Alright, I don't know. I might not copy this down. So we making that whole thing. Well, the u goes down here, and its derivative goes up top. So 1 over 2 rad x goes up top. Yeah, I don't like this way. Now if I clean that up, yeah, that's just 1 over 2x. Oh, that would have been so cool if they would have both been lovely, but oh well. Nope, we're not adding radical. So we chose the wrong u. The du, sorry, can't get there. That's crazy. Right. So that's what we're going to do. Okay, well, let's start it out. So we're going to make u just the square root of x. This is 20. It's nice when you just know that by heart. You don't have to think about what. So nice. What are we doing? What are we multiplying by on the inside? F on the inside, so we're multiplying. I still want you to say add, even though I know what you're saying. But we're multiplying by a half on the inside, so we have to multiply by 2 over 1 on the outside. Now it's time to convert it all. Okay. Well, before we get to the limits of integration, let's compare everything else. We have the 2 out here. What do we have in terms of just u and du for the integrand, what we're integrating? That's the ln of u. Is it over du? Times du. Right? See that? Yeah, now we got to change the limits of integration. If it's a definite integral and they're telling you, we want you to convert the limits of integration, use what u equals to get the new. So when x is 1, what does u equal? 1, because remember, u equals the square root of x. So that's just 1. You look at the u statement. So the lower limit of integration, that was x equals 1. U is the square root of x. So U is the square root of 1, which is still 1. Because I just take the x value and I plug it in here. Okay? So now let's get the upper limit of integration. The upper limit of integration was x equals 9. So yeah, the upper limit of integration is U equals 3. Because U is the square root of 9. We've converted the limits of integration, so once we get the antiderivative, we're going to plug into 3 to 1 and subtract. Finish. Oh, yeah, that's parts. But this one you might just want to memorize. Oh, yeah, then you got too many U's. That's like George Foreman naming all his kids George. That gets confusing, yes. Oh, yeah, you wouldn't have to. But if on the test it says including, because I think on one of these I wrote convert the limits of integration, so then I would take off. But normally it doesn't matter. That's what it says. Okay, so here's the thing. You just might want to know for the BC exam the antiderivative of the ln of x. This is the ln of u du. Sweet. It's to integrate the ln of x. Throw something. What can I throw without getting hurt? Oh, I know. I was trying to throw something. Well, you can. That's true. You don't get written up. You were turned completely. I feel like I was being shot or something. Alright. Alright, now here's the thing. I'm going to just, show you how to get the antiderivative of the ln of x, and then we can just use the formula. I don't want to have like u's and everybody, it's going to be too confusing, okay? So in general, if you want to get the antiderivative of any inverse trig function for the ln of x, you use parts, okay? So what's your u going to be for the parts? And what's the dv? So what's du? And what's v? So now we can put it all together. So we have the integral of u dv, the ln of x. So x ln of x minus the antiderivative of v du. X times 1 over x. 1. It is, right? We know what the antiderivative of 1 is with respect to x. Just x. See, if you did product rule on this, first times to the second plus second times to the first, then you subtract x, you're going to wind up back to ln of x. X ln of x minus x is the antiderivative of ln of x. Because if you take its derivative, you get ln of x. Oh, yeah, so now we know what the antiderivative is. So let's finish our problem here. Oh, sorry, it has to go. You're going to have to memorize that. So we have the antiderivative of ln of u du. What's that going to be? U. Ln of u minus u. Right? Now let's minus times 2. We have to go from u equals 1 to u equals 3. This is a lot. Crazy. What does every technique have u's in it? So let's see. I'll keep the 2 out here. So we have 3 ln of 3 minus 3. That's what I get when I plug in the upper limit. Minus ln of 1. Like that one. Minus. And the ln of 1 is 0. This is fun. Alright, 2 times 3 ln of 3 minus 3 plus 1. So that's 2 times 3 ln of 3 minus 2. Wow. Yeah, it was definitely a lot easier if you knew what the antiderivative of L and of X was. I mean, that would just be a problem and a problem. You lose interest. What? Yeah. Just spend a day on it. It's one problem. Uh, but yeah, you okay with that? When you convert everything to USD, you just look at what U equals and just figure out the lower and upper limits of that. What were you saying, Melanie? Let's see. Can you tell me what it is? Finally, someone else one of these. Oh no. Okay, first of all, when you look at this, are you thinking, oh, inverse trig? No. Because if the x wasn't up there, then it would be an inverse trig. It'd be like an inverse sine. But because you have that x up there, it's going to be regular old U sub. But I will pull that 3 out. Yeah. Yeah, you have an, if the degree up here is 1 less than the degree down there, it's going to be U sub. But if the degree is 2 less, then you're... So I would pull the 3 out front. Anytime you have a constant multiplier, just get it out of there. So even though you're probably thinking about inverse sine, you don't need it. Yeah, it's just U sub, so what's U going to equal? 9 minus x squared du, negative 2x dx. Let's put in what we need. Factors of U that we need. Negative 2 on the inside, negative a half on the outside. Now we rewrite it in terms of U into U. See, we don't have any limits of integration this time. It's nice. What does it look like when I rewrite it? Du over du. Gotta think of it as U to the negative a half. I'm writing that. Don't tell me that's an ln. If it's not just U over U, don't say ln. So U to the negative half. And now we use a power rule. It's the antiderivative of U to the negative 1/2 du. Just write that. Alright, what's the new exponent? Now you're right. Half, and so you have to multiply by 2. Right? 2. Those cancel. And so our final answer is negative 3 times the square root of 9 minus x squared. Surprised we haven't asked any inverse trig, though. Yes. Okay. What is it? Yes. What is it? So let's just get that 5 out of there right now. Okay? So we know we're going for an inverse trig. There's no x up there. So before we can do anything when it's inverse trig, that has to be a 1. So what are you going to do? Yeah, you're going to divide out the 36, but it's under a radical, right? So we're really pulling out I'm going to leave it square root of 36. I'll make it a 6 later. Now, so we're rewriting this radical as a product of that radical. So what's this one in here? Minus 4x squared 36. Now, if you're not sure if you factored it right, I always distribute. So now out front, we've got the 5, 6. Now, yeah, so getting the 1 is the one extra step. And what's that other extra step? Identify U squared. So what is U squared going to be? Yeah, never make U squared negative something. That's something I see kids do. always, no, it can't, right? Then they get stuck. Every time. So then you get u. So by taking the square root of 2x over 6, should we make it a third x? You want to leave it? Yeah. So du, Delia, you're too comfortable. Du is what? 1/3 dx. So now we just got to put in the third on the inside, and 3 over 1 on the outside. So I already started writing that. So now it's du over the square root of 1 minus u squared, 5/2, which is that one? Inverse sine of u. And then we just got to put u in, not u squared. 5/2 times the inverse sine of x over 3, or 1/3 x. Let's see. Oh, so that was not too bad. Now I get that? No. Now I stop this. See, Ryan. But I am